Hello everyone, my name is Louis Talley with Aviva, and I'm privileged today to be here at Proveit 2026 to show you our offering that we have around Crosser. So you can see that we've got Enterprise C, our data ops tool Crosser, and we have this deployed into a Linux Docker container in AWS. And so we took a look at the data within Enterprise C, and we said, what are the value add things that we think we can do to bring immediate value to the solution? And first and foremost, when we looked at the data within Enterprise C, we noticed that it was very unstructured and unorganized. Much like if you think back to the days of traditional HMI SCADA, where you have a tag that's unstructured, think about that, and then moving to a more modern SCADA infrastructure such as System Platform allows us to put the model view in place to handle structured naming conventions. So we applied the ISA naming convention to this data set. We did that using the Crosser tool. So that's value add step number one. So we tackled some other scenarios as well. So here's the unstructured data within Enterprise C. So this is everyone's data here at the conference being published into an MQTT broker. So notice the flat unstructured data. No meaning really to this other than hopefully I had a good naming convention. So what we used Crosser to do, this is a Crosser flow that allows us to pick that data up. So in a number of logical steps, we went through and we subscribed out to that data via an OPC UA interface. And from there, we picked up that data, we cleansed that data, looked for good quality data. So Crosser being a good data manipulation tool and a tool that allows me to pick up data, manipulate it, transform it, massage it, cleanse it, pass it along through pipelines and do something with it. So a logical environment, I'm doing stuff here. And so as information flows through here, I transform it. And by transform it, meaning I add a resource mapping to it. So we used AI to look for pattern naming inside of the structure of the OPC UA client to provide a folder structure for us. We used AI to help us extract that out. And then from that, we built these rules to process the data. So we basically split it into the telemetry data, as well as the data that describes the data or the metadata here. So you can see the path that each one takes. And I'm not going to do that now, but if I were to put this in debug mode, you can actually see as the information flows through each one of these activities, what transform is happening. So I can see that I call it the goes into and the comes out of. So when data comes in and when it goes out, I can see what it looks like before and after. So a very powerful way to troubleshoot how data is moving through your system to better understand, in real time before problems occur. So the real magic happens where we come in to look at some of the settings for some of these flow activities here. So basically this is where we perform the mapping, where we say, hey, we're bringing this in a pretty little JSON object, as Bob Ross might say, and we're sort of painting a picture with it. So we're saying, this is what I want to call it on the left, or here's what it is on the right, and I can go in and manually perform that mapping. So from here, we execute these steps, we take all this data through this data pipeline, and then we publish that back out to the MQTT broker for the conference. So pretty simple, pretty straightforward, not a lot of complexity here. When we look at what that looks like here, you now have a structure for Aviva, bioreactor, sub 250, controllers, and then each one of these temperature controllers, we set up that model for. So you should now be seeing what the 95 modeling structure looks like when it's been applied to Enterprise C data. And so that was step number one. So we said, okay, that's cool. That's going to be very beneficial and valuable for customers who are struggling with what standard do I use to come up with an equipment naming model, or they may have called things different from plant to plant, or engineer on one shift calls it this, the engineer on the back shift calls it that. So this is a great way for me to build a UNS to enforce global naming standards where I might not have an infrastructure in place that can do that for me, such as System Platform that allows us that ability to model and control that naming. So the great use of the tool to be able to very simply, very powerfully apply that to the namespace. Said, well, we think we can do more, and we can. So let's take it a step further. Let's process that data. Let's do some intelligence on it. Let's show our customers some of the types of things that we can do with this tool. There's over 800 different connectors and adapters within this tool that allow me to do very powerful things to my data. It's one thing to be able to move data, but to be able to transform it in some meaningful way to get value out of it, that's a whole other thing. And so that's what we attempted to do with use case number 2, which was detect anomalies and again, publish the results back. So what does that look like? So here we are back in the Flow Studio, and we can see that the way that we built this flow out was we're doing a couple different things sort of in parallel here. We're going out and we're grabbing all the equipment set points. And parallel, we're also grabbing all the process values. And so we're doing that and we're stuffing them up in this data space and memory called a real-time window. So what that allows us to do, in this case, we're stuffing, I think, 20 points up into this real-time window frame, and we're going to do some logic on it. So we could be doing other types of AI or machine learning on that. We just wanted to show you that we could actually highlight and execute Python code directly from within here. You might be doing something totally different in your environment, and that's completely okay. So but we wanted to sort of show you, and this is not a lot of complex logic that's going on here. We're basically just looking at the delta. We're looking at the change in the absolute value of the process value minus the set point, and then we're sort of providing like a ranking or a weighting to that, and that becomes our anomaly score. What we're doing is we're actually that calculation in a loop, and then we're actually modifying this JSON object here, this output message, to actually say, hey, there's a problem. Houston, there's a problem, right? And so the end result of that, once we go through that step, is that we publish that back out to the broker for the conference. So we update the timestamp and we publish that back out to the MQTT broker. And so then everybody here at the conference can see that. So if we go back and we look at the MQTT Explorer for that particular asset that we were just looking at, you can see that I've modified the payload here to incorporate that I have detected an anomaly, as shown right here. And so we've walked through 2 use cases. We've walked through applying a structured naming convention to it, doing some value add activities, in this case, just a real quick anomaly detection. And we saved the most complicated for last. One of the things that, if you happen to notice the naming convention as defined within how everybody maps their stuff in, it uses a backslash as a delimiter. And so one of the things that we wanted to do was publish this out to our cloud platform called Connect, specifically Connect Data Services, and you're going to see also some stuff with Connect Visualization. We use a dot as a delimiter. So you'd think that's pretty complicated to solve. Turns out it's really not. So again, Crosser to the rescue. We built this highly complex flow of like 2 steps that basically just shows some of the simple power that you can do with string and pattern manipulation. So basically, Aviva Connect wants dots as delimiters, and our OPC driver uses slashes. So we basically open it up and we sub dot for slash, slash for dot, and then we move it through the pipeline here. And so here's an example of one of the drivers that was written. So this Crosser technology is extremely open, extremely powerful, technology agnostic. So you may have noticed in the other examples I showed you, we used an MQTT publish flow. Well, this was a flow that's written for Connect to directly put data into Connect. Connect is a very powerful tool with many ways of ingressing data. And now with Crosser, we could take that a step further because we now have a native way to put data directly into Crosser by just filling in some authentication parameters, and I won't go through all of them because it's got our namespace. So in summary, what have we done? We've read all the data in, we've structured all the data, we've shown you that you could do things with the data, transform it, manipulate it, massage it, cleanse it, move it around, and then we did stuff with the data. One of the things I wanted to really briefly talk about was also the ability to centrally monitor, administer, and manage all of these flows that are running. One of the things that's very powerful about this tool is, I mentioned very briefly in the beginning, this can be deployed. In this case, we have it deployed to an AWS to a Linux Docker container. This can be deployed in a native sandbox. This can be deployed in an edge device, a Windows device on premise. Very, very flexible in terms of how we deploy it, but a very powerful orchestration tool that allows me to see what's going on with each one of my flows, manage it from here, deploy it from here. We've got some very powerful version control built into it. So if I have version 3 where I made a change and I want to revert back to version 2, or I want to build a new flow off of version 3, I can do that. Of course, a fully integrated security model. And now I'm going to spend the next 8 hours going through all 800 of these flow adapters. No, I'm kidding. But this is just a very quick overview of some of the adapters that we have, some of the connectors. We've had lots of questions over the conference. Do you talk to this? Do you talk to that? And we're very software agnostic, very open. So we talk to lots of different stuff, whether it's industrial protocols, external systems, databases, etc. So thank you very much for taking the time to watch this video, and we look forward to Proveit 2027.